Okay, I'm using low light. I'm not using my flash to conserve the battery. So I think I'm on the verge of figuring this thing out. One last detail, I have to verify the whys of that, because answering each question leads me to a new question that I have to answer. So I don't have all the questions answered, but I think I've got it generically down pat. It all has to do with the relationship between frequency and voltage. And this neon bulb raises the voltage here because it raises the frequency here. And that has an impact here. And the Earth makes up the difference the only way it can. Oh, wait a minute, let me get my other schematic diagram. So what this is supposed to represent, this is an enclosure. See, this is a black and white. So basically this was red with a green border, and this was a red block with a green bar separating another red bar or block to the left, and then my neon bulb over here. So what this represents are several things. First of all, the neon bulb. Secondly, the two sets of grounding rods, the 56 over here in this block, and the 4 in this tiny block that's on the other side of this green band going down, which is the Earth separating the two blocks of grounding rods. Then this block here is the Earth, and it's got the same color separator as does here because it's the Earth. So what happens is the neon bulb raises the frequency of the circuit at this point, which also raises the voltage at this point, which is connected via the load if the load is on. If the load is not on, then it's connected by this short over to one of the primary wires here. No, excuse me, it goes over that. It jumps over that, goes directly to the electromagnetic keeper, which is inductively coupled to the Captor loop, which means that it gets directly carried down to this block here of grounding rods, the larger of the two blocks. Now, it also goes to the lead of plug number 1 of the sine wave inverter, but the sine wave inverter is a fixed 60 cycles per second. But what if the internal wiring is such that it grounds out to the neutral? It could be that the high frequency voltage does go to neutral ground, which means it'll go to these 4 grounding rods going down the middle, which corresponds to this very slender block, red block over here on the other side of the green block, separating the two blocks. Now, the reason for the two blocks is to show that the mass is different between the 56 grounding rods on this side and the 4 grounding rods on this side of the Earth. And to counterpoise that with this, which is not done to scale, which this should be really much larger than either of these combined, and this represents the mass of the Earth. And the bar separating them is the semi-dielectric, the semiconductor, semi-insulating, separating these 3 blocks of magnetizable material, because that's what these represent, magnetizable material. So now we have a discharge, a disruptive discharge, raising the frequency from the 60 cycles. It's dirtying the pure sine wave of 60 cycles by adding in an element, a minor element in terms of amperage or amplitude, of high frequency, which raises the voltage. And I'm going to get to that in a minute. That's not an entirely answered question in its own right, but that relationship has been established by Jim Murray in one of his prior experiments. He lectured on that topic in 2013 conference in Hayden, Idaho. So that question I don't have answered. Why does voltage raise in concert with, directly raise with frequency? But the fact is it happens. He doubled the frequency. He did an experiment with a substation, isolating it from the rest of the grid. His friend was running it at the time. They doubled the frequency, and I think it quadrupled the voltage just by doubling the frequency, something along those lines. Well, that's, pretty cool. So, what I think happens here is that the neon bulb considerably raises the voltage of the 56 grounding rods, which means this mass right here now has a much higher voltage potential than the 4 grounding rods on this side. Now bear in mind that the sine wave inverter keeps everything regulated at 60 cycles, but the grounding rods are separate. It only keeps the inner electromagnetic keeper regulated at 60 cycles and at 115 volts in this case. So anything extra gets to happen down here among the grounding rods, which, according to Clarence, works best if they're steel, which, according to Tesla, I think, is the analogy that if you add more mass to this block, more iron mass, magnetizable iron mass to this block of grounding rods, you increase the output of the overall device. But all you do is add to what's already there. So you could have 4 grounding rods here and 4 grounding rods here, and it would still work. It just wouldn't have as high an over-unity, as high a COP, coefficient of performance, as it would have otherwise. And also you need to be in a nice highly geomagnetic area of the Earth to take advantage of the Earth's input to this. So what happens is you raise the frequency, you raise the voltage. Now, let's see, what was I thinking? It came to me in the bathtub. Let's see if I can remember what it was. This block here is going to have its frequency and thus its voltage raised with respect to this narrow, small block of 4 grounding rods over here. And the Earth is going to make up the difference. Because it's not, see, this is like a capacitor. In a sense, it's a capacitive situation. It's inductive, but it's looked at in the same way in that you've got the dielectric in between, and both sides have to be balanced, and it's not going to be. Because this side is going to respond very favorably to the raise in voltage, while the other side is not. The other side is going to have like a choke effect on it. While this side, because it's relatively not choked because of its larger mass, is going to be able to go along with the raise in voltage, while this other side is going to get choked. And so the Earth is going to have to make up the difference to supply a polarity similar to this side, but matching this side in magnitude of whatever is going on here, due to the influence of this here. So it has something to do with raising the voltage, because this is all about voltage. That was somebody's analysis. I don't have the schematic in front of me, but in order to supply more amperage here, the amperage of the electric keeper here has to go up, and prior to that, the voltage potential here has to go up. And that's done in a small way, but significant way, because when the frequency goes up, the extremes also go up, and that's why the voltage goes up. For some reason, when the frequency goes up, especially when it's cacophonically disruptive going on, chaotically disruptive, there's no regulation. See, the whole point of electricity is we have a nice regulated sine wave, 60 cycles, and then we get something disruptive, and on top of which, it's high frequency. It's not just low frequency disruptions, but high frequency, which makes it even more disruptive to the entire symmetry of the system, and the Earth is going to have to make up the difference, and it makes up the difference because A, it's going to have some magnetic field here of some degree, and B, because this side is larger in mass than that side. But it's all about in response to what's going on with the neon bulb. So the neon leads and the Earth follows suit. And it follows suit with voltage, which is inductively coupled to the electric keeper here. And the electric keeper is directly shunted, connected to the power lead coming from the sine wave inverters. So this is fixed at 115 volts or 120 volts. So the only thing that can go up here is amperage, and it'll make up the difference with the help of these transformers. That's why he has 2 of them, because the electric keeper alone is not part of it. It's an electromagnetic keeper. It's part and parcel. It's integrated with these 2 toroids, which again are fixed because of these primaries supplying a fixed voltage and a fixed amperage. But amperage can go however high it wants to inside this keeper. It's only the voltage that's being regulated. So actually, why do we have to have a shunt here? Oh, Because this is plug number 2 and plug number 1, and they're independent of each other. That's why. So plug number 2 is supplying the voltage for these transformer toroids, which is all very well and good, but it's plug number 1 that we're using to power the load. And so we have to have, because of slight discrepancies in the circuitry, because it branches and separates into 2 separate plug outlets, we have to make sure they're totally in sync. And so we do this voltage shunt between plug number 1 lead and the electric keeper, not plug number 2 lead. Why? Yes, why the difference? Why not go down to here instead of up to here? Or do both of these? Good point. That's a very good point. It's an excellent point. Well, I don't know. Oh, you know why? In this instance, the lead here goes to the top of the toroid. I'm guessing here. But the neutral goes to the top of this toroid. The neutral from plug number 2. So the lead and the neutral cancel out, and so you can't even use this because of that inversion. That's what it looks like. Yeah. Well, no, you know, that doesn't make any sense because the inner electric keeper does the same thing. So why do you go to the... See, I don't have all the answers. I still have questions left unanswered. But at least I know somewhat more how this works. It raises the frequency in order to raise the voltage, and it draws it from down here because of the difference of the 2 masses of the 56 versus the 4 grounding rods. So that's all I've been able to figure out. I still have more questions to answer. You know, why is this shunt connected to here and not to this line in here? That's a very good point. Well, because it's this secondary that's supplying the power load. Yeah. That's why. It's a single stage transformer going from plug number 2 to plug number 1, and it has this intermediate step in which the earth gets to get involved to integrate what's going on. So the earth is contributing to the secondary. It's as if we have 2 sets of primaries. One is coming from the sine wave inverter, and that's our seed power. The balance is made up for by the earth. The question that though remains still is, why do we have to have this at all? Oh, because the earth is coming in at a very high voltage and we still have to have this fixed. Okay. Let's see. You know, when we pass this energy through a transformer from plug number 2, it's already being varied. But the sine wave inverter is not designed to go through a transformer to supply a load. It's designed to power the load directly with nothing in between the load and the inverter. And so that's why we have to have this shunt go from the lead of plug number 1, because the electric keeper has to be represented directly through a single line, an open line shunt to the power lead of plug number 1 going to load. To the power circuit of the lead of plug number 1. But it's only represented in terms of voltage, which means, since this is a step-down transformer, the voltage is being lowered, but it has to be raised back up again. That's odd. that means the voltage of this line is going to drop because we've dropped it down. Not because it goes inductively to earth here, but because the transformer drops the voltage. If these two plugs are putting out the same voltage, then the lead of plug number 1 is going to drop because it's being shorted to the secondary here. Because the secondary has a stepped up amperage and a stepped down voltage. So this is going to drop the lead voltage here. Which means in order to power the load, we've got to step up this voltage again. Without, oh dear, see what weirdness this is? We have to step up the voltage without adding more voltage. That doesn't make any sense. Oh no. We have to increase the amperage without changing the voltage. No, that is weird. Because we have 2.5 loops here, the Captor loop, same as here and same as here. So the voltage coming down to the earth through the 56 grounding rods from this electric keeper is the same voltage as what's in the keeper, which is less than what the primary coil is supplying to the toroid. It's stepped down by a factor of, where's the figure? Oh, where'd I write it? I don't think I wrote it here. No, I didn't. I wrote it on another... Oh, here it is. Okay, let's try doing it this way. 242 turns versus 2.5 turns. And the secondary is, well, it says 2 to 3, but that means 2.5 basically. So if we double it to 5 versus 484, 484 is nearly 500 turns. So 500 to 5 is 100 to 1. So, oh dear. So we've stepped down the voltage by a factor of 100, which means now we only have a little over a volt. But the amperage is very high. We're only supplying half a watt. So this is around 50 watts here now. Still not enough to supply our load in any substantial amount, but, you know, modestly. But the voltage is too low, so it's not going to satisfy this at all. So basically, we've cut off the ability for the sine wave inverter to power the load because we've drastically reduced the voltage. And if we don't do something from the earth, nothing's going to happen over here. It's simply going to drain the battery. Somehow. Yes, how is that somehow? How can it run at all? See, the battery goes to here. Well, if these fail to make connection to the earth current, that's one problem. The other problem is that if there's not much difference between them, they won't make much connection to the earth current. Because if these two masses are the same, if this mass and this mass of grounding rods is the same quantity of mass, there won't be any imbalance, and the earth won't be required to make up the difference. So it's not just a question of how much earth contributes, but whether or not the earth can contribute at all. And it's predicated on 2 points. Only one point is the neon bulb, but the other point is the difference in mass between the two sets of grounding rods. So we could have 5 grounding rods over here and 1 grounding rod over there. And if there's enough strength of magnetic field coming from the earth, and the neon bulb is doing its job, then we should be able to get enough energy from the earth to power our load. But this would have to be pretty strong to make up the difference. So there does have to be a difference between these two masses to be able to suck up any voltage from the earth at all. But there also has to be a lot in the earth to suck up, or else we've got to increase this mass over here so that the sucking action is greater. So than it would have been otherwise. Or we increase the disruption over here by raising the frequency, if we can do that. But if we can't raise the frequency any higher, then the only other thing to do is to either raise the mass of this block of grounding rods, or, inclusive or, find a location that has a stronger geomagnetic field. So obviously I still don't have all the questions that could be posed answered. But at least I've tried to answer as many as I can at this present time. But it takes practice, over and over again practice. But at least I understand now what this has to do with voltage, because this is a direct relation to voltage, even though all this does is add an element of dirty electricity into the circuit of a very high frequency. And it'll automatically induce a rise in voltage down here if this is configured correctly. If this is not, if we even take this out, then we won't get any rays of voltage coming into the Captor loop here, even though this is prompting it. Now obviously then, this bare wire ain't going off to nowhere. It's going off to the air, and the air goes to back to the earth. So it's making in a complete loop. And that's why the rest of the circuitry has to be totally insulated against shorting out between any point in this circuit and the bare wire, antenna wire coming out of this neon bulb. And this wire can be a plate to increase its surface area to provide for more response, to make it easier for this neon bulb to light up. But we still have to have response down here of a voltage orientation to counterbalance the rise of frequency over here. Or else there'll be no added energy added to the system. Because unless we add voltage to this electric keeper, the amperage in the electric keeper is not going to go up and supply the load. Now I'm still worried that the voltage, I've always been worried, I never bothered to answer because I don't know how to. If we step down the voltage, how can we possibly supply the load? Oh, I know how. Because it's coming from here. So the voltage goes up here, and that induces a voltage difference between here and the lead up here. And because this is connected by this lead, by this shunt, to the electric keeper here, you know, it skips over here. You see the little bump there, so it skips that wire, goes directly up there. So that means that this side of the load is extremely low. It's what the keeper is. The keeper is, what did we determine, 100 times less? Somewhere around 1 volt. So one side of this is 1 volt, and the other side has to be 100. And it's not going to come from the neutral of plug number 1, because plug number 1 goes to the 4 grounding rods in the center of the earth. It has to come from the 56 grounding rods, inductively coupled to the Captor loop, but nonetheless, so there has to be enough voltage here to supply 100 to 1 difference, plus have enough left over to beef up the amperage in this electric keeper portion. Because it's the circulation of this closed loop in the electric keeper that's going to make the movement of amperage possible over here by way of induction here at the Captor loop. Sorry for the lack of focusing. There we go. So, so let's see. If the voltage is coming in at a very high rate from the 56 grounding rods, very high voltage, how does that translate to amperage? Well, because the sine wave inverter from plug number 2 is regulating the voltage on these toroids. So the electric keeper engages the toroids, and the toroids say, look, we don't accept anything higher than a specific amount of voltage. So, that regulates the voltage of the keeper at 1 volt. although the amperage is free to rise, the voltage is not. And so the excess voltage has to continue on through the Captor loop, back the other side of the Captor loop, through the Captor neutral is what I like to call this, the Captor neutral, to go down here to the neutral side of the load. Which means these transformers literally transform the voltage coming from the earth, not just the voltage coming from the primary, coming from the sine wave inverter, but coming from the earth as well, to reduce the voltage coming from the earth to be 100 volts, 115, to match the 1 volt on the other side here. So there's 100 volts difference. And any excess voltage gets converted into amperage. All due to the toroid doing the conversion. I knew it. I knew the toroids were converting the energy from the earth. I wasn't sure how. But since the loops here are 2.5 counterclockwise, just like the Captor loop is counterclockwise 2.5, the Captor loop is also counterclockwise, just like these two secondary loops are counterclockwise. And they're all three of them are 2.5 loops. So the voltage level is the same on all three. And the voltage is fixed in the toroid due to the two primaries. And the keeper is in phase with the primary of plug number 1 going up here, which is just 1 volt, because it's been reduced and tied to the keeper. So the only thing left to vary is the amperage. The amperage gets stepped up. So it's... Why is it a step down voltage? That's the question. Why is it a step down voltage? You know why? No, I don't know why. Must be the circuitry of the sine wave inverter, because it's coming from here. You know what? Maybe if this voltage goes up, the line coming from plug number 1 goes down even more. If it's idling, if there's no load over here, this will be 1 volt on the top. And it's probably 1 volt at the bottom as well. But if extra voltage comes in here to supply the load, then the extra voltage actually has to go through the sine wave inverter and then come back out through the neutral. Or actually... Yeah, I bet you the sine wave inverter varies the lead coming out of plug number 1. The lead of plug number 1. It'll drop that voltage down by a significant factor in order to counterpoise the voltage coming from here, so that the end result is 100 volts across, 115 volts across the load. And in order for the sine wave inverter to do that, so this will probably convert the voltage. And the excess amperage will probably come out plug number 2, beefing up the amperage of the keeper. Because a little... Well, if that were the case, then the lines coming out of plug number 2 would have had to been bigger gauge. But it's not. This is 10 gauge. And this is 4 gauge. So you see, I really don't understand how this is able to convert the excess voltage. I still don't get it into amperage. Oh, wait a minute. Let's see. if this voltage goes up in here, it can go to here. It could go down to back to the sine wave inverter, but the sine wave inverter is fixed. So actually, by these connections here, it'll go over to the other one. It'll go back and forth. It'll go to here and get stepped down. Huh? And still come back out here. Huh? Boy, this is so bizarre. Yeah, there's some mechanism going on here to regulate the voltage and come up with an extra amperage. And I'm not quite sure what that is. How that works. Because we can't use the load to modify voltage and amperage in here, and we can't use the sine wave inverter either, because that's a kind of a load and an appliance that's a regulated internal dynamics also. And somehow this has to be able to work with just one toroid, although it works more efficiently with two to do the conversion. I think the faster you can do the conversion, then the more voltage you can accommodate coming from the earth. And so maybe that's the advantage of two toroids, is the speed, the rate at which the voltage coming from the earth is converted into amperage. I'm still not sure how, though. Maybe I should stare at this. Let me turn this off for a minute, pause it. There's only one conclusion I can come to. And it only took me a second to think about it. Back EMF. Anytime we have an inductive coupling, back EMF is going to be possible between a piece of wire, the coil of wire, and the straight piece inside of it. So we have an inductive coupling here, which means back EMF is possible. But we have it to a greater degree here because this is magnetizable. But we still have it possible here too, because it's a loop of wire around a straight piece of wire. I mean, a piece of iron is a kind of piece of wire, sort of. Must be why they wanted to use ferrite, because then that prevents electricity from flowing. Ferrite is a composition of ceramic material with iron particles embedded in it, which means you're trying to create resistance, more or less a dielectric material, so that no electricity can flow, only magnetic flux can flow. But in the wire you can have electricity flow. So that's why this has to be ferrite. So where was I? So there's a back EMF situation in which the voltage coming out of plug number 2 is regulated due to the primary coil. So if you start feeding in a higher voltage, which is basically a disruptive voltage at higher frequencies, because set up by the neon bulb, and that's when it's going to come back from the earth, is a high voltage, high frequency situation. So the sine wave inverter is going to force the magnetic field in the toroid to be fixed at a specific voltage. So any high frequency voltage coming into the toroid from the earth is going to come right back out in the opposite direction. Which means what? Well, it's going to counterpoise it. How can that step up amperage, though? If anything, you would expect it to be negative resistance, not positive resistance. So it's not just a cancellation of the so-called lens effect. It would be the inversion of the lens effect. Or else how can we have a raise of amperage instead of its reduction? In other words, we're using the inefficiencies of back EMF to actually improve efficiency and become over unity. That's what it sounds like, somehow. So I had a lot of questions here that still need answering. So we are using the lens effect to our advantage, but it's now a negative resistor, basically. In the interaction between the electric keeper and the two magnetic keepers. How, I don't know. But that would have to be the case. Because why else would we be able to convert all the voltage coming in from the earth into a raised and elevated amperage inside the electric keeper to serve as the driving force, inductively coupled through the Captor loop to the Captor neutral, supplying the neutral of the load. Now I have another problem. Supposedly this is three-phase power, or else we wouldn't be calling it a lead versus a neutral. A line versus a neutral coming out of either one of the plugs. Which means the three phases of power coming out of the line is garbled to the effect of neutralizing it on the neutral leg. Which is what the earth represents. Is zero phase, a neutralization of the three phases. Which is kind of weird. So that means we really have two components interacting here. We have three-phase power and neutral power interacting, which is not unusual because we've got the neutral line of plug number 2, the neutral of plug number 2 going into the toroid, and then comes out the other side, the line of plug number 2. Let's see. Well, each phase of a three-phase power is only 1/3 of the total angular force applied. It would be like three people pushing a car, and the full cycle of push, draw back, and push again is set off phase by 120 degrees, by 1/3 of a cycle. So it's actually, no, it's more like three people hammering one of those nails into a railroad, and you have three guys, and they're hammering each in perfect succession from the other, or towards the other, creating a full cycle among the three, evenly spaced by 1/3 of the entirety of all three combined. So it's like you're hammering away pulses. Actually, no, what it's like is having three AC cycles combined, but offset so they're out of phase by 120 degrees. That is weird. Oh, that makes things more complicated to analyze this. Possibly. Yeah. Because that means the Earth doesn't have any phases going to it. What does it have then? Oh boy, do I have a lot of questions to answer. Oh my God. See, if it was single phase, it might not work. And much better than if it were direct current. Maybe that's why AC works better, is only if it's three-phase or, multi-phase, polyphase. according to Eric, 4-phase is of nature, and so maybe 3-phase is not natural, and 4-phase is, and maybe that's why electric power is so disruptive, because it's not 4-phase. Be that as it may, whatever is the case. So there's more to this, requiring the analysis of what's going on between 3-phase and neutral, between the line and the neutral. So I would have to assume that this Captor loop is a neutral connection, while the shunt here is not. The shunt is 3-phase shunt. So maybe that's why there has to be 2 connections, and why this has to be a direct connection, a direct coupling, a hard coupling, because it's supplying 3 phases to this electric keeper to ensure that it's not only in sync with plug number 1, but it doesn't fall out of phase due to the interaction with the earth that's inductively coupled over here. So this is definitely meant to keep it in phase. All the more reason, since you've got 3 phases, to stay in synchronicity, not just one. Makes it even more complicated. Makes it even easier to veer off, this electric keeper to veer off out of phase from plug number 2, to become out of phase because of this. It's not enough that it's inductively coupled through the toroid to the primary coil coming from plug number 2. It has to be directly coupled to plug number 1. So that's all plug number 1 is doing, is providing in-phase synchronicity with either if it's 1 phase, or even more important, if it's 3 phases, it's got to be in sync. And the consequence is that the voltage of this line voltage up here is going to be dropped down to the voltage of the electric keeper, which is going to be somewhere around 1 volt, more or less. Which means it'll be impossible to power this load unless we get something from the earth to make up the difference. And we could get something from the earth. Let's say if it rains and it shorts out the semiconductor, or it shorts out the semi-dielectric of the earth between the 2 sets of grounding rods, the 4 grounding rods versus the 56. So then that short provides a perfect pathway for the neutral line to jump across the earth and make it impossible for the neon bulb to have any influence at all on these 2 different masses. So this separation here has to be a dielectrical one. It's going to be imperfect, it's going to be a semi-dielectric, but it has to be a dielectric. If it's complete conductor due to shorting during a rain, let's say, a rainstorm, and salty earth for that matter, then this difference between the 2 masses has been neutralized. Now it's like they're equivalent, the same mass on either side. And it's as if they're not even there. Because this divider is also going to be shorted out. So it's as if the grounding rods won't even be there when it rains, let alone difference in number between the 2 groups. It's like they're not even there. It'll be as if you just had, no break at all, and you just had a wire go across here. And so that'll mean that the neutral will be the same voltage as the line. Well, no, it's a neutral, so it's not going to be the same, right? So now the line is going to be 100 volts, and the neutral is going to be, like 1 volt. And that's it. You won't get any over unity, and so everything comes out of the sine wave inverter to power the load. So it does make a difference that we have a break here between the two groups of grounding rods, and it makes a difference that there's a difference in mass between them, and it makes a difference that they're rods and not a solid block of metal, because the rods break up eddy currents. So I don't know how you would fix that problem. Well, you could fix it in a hull of a U-boat or in the chassis of a 1931 Pierce Arrow car if every piece is insulated from every other piece. You know, the car that was outfitted for Tesla for his demonstration may not have been just come right off the assembly line unless it was built a certain way in which there was insulators among all the pieces that are assembled together. And if they weld them together, then there's no insulation unless the weld, the composition of the weld, well, no, the whole definition of a weld is that you get the two metal parts to bond. That means the metal itself has to be more similar to ferrite than anything else. That's right. And that way the eddy currents will be broken up. Otherwise, you may have a problem with the eddy currents alone. Apparently, this is, yeah. Not that it couldn't work. It would just be more efficient. So it could work if they were not separated. So it could work if these were not grounding rods, and if we simply had two masses of iron, one here versus one here, two blocks of iron. But it would not be very efficient because of all the eddy currents. They were very large eddy currents. But the grounding rods are actually more efficient because they're individually separated from each other, because the only connection between them is copper wire, and so the magnetic flow is broken up, individuated, isolated among each grounding rod. So that's actually an improvement of efficiency, is to use grounding rods as opposed to just two masses of iron. But you can make up the difference if you have a lot of iron. Then you could really create a difference between these two masses. So there's a lot of leeway, here. And then, of course, you got the magnetic field of the Earth as well as a factor to play with. Okay, did I answer most of my questions? Let's see. Maybe not. Probably not. I doubt it. But at least I've answered a few, and the most important one is how does the voltage go up, or how can the possibility for the voltage to go up here, because we've raised the frequency here. So I'm now going to look at in that lecture for the direct quote from Jim Murray, because he had to perform that experiment to learn about that relationship. Apparently it's not taught to electrical engineers that when you raise the frequency, you automatically raise the voltage by a value greater than what you did to raising the frequency. And he found he doubled the frequency and he quadrupled the voltage. So that alone is just stupefying, because this is going to be high frequencies up here, which means that the voltage here is going to be huge. Oh well, it's the best I can do at the moment.